So how did the Mayans count to such large numbers? This is actually a really fascinating subject for me. So very quickly, this says 8 right here, this says 4, and this right here says 13. Now, let's break this down. So the Mayan counting system is pretty damn efficient. Instead of remembering 10 different numbers, you only have to remember 3 different symbols. So instead of just thinking that these dots are ones, they're the one position. So here, since we're starting from the 0 position, this actually counts to 4. Now the bars are going to represent a 5 count, so this is going to add up to 15. Now last but not least is the 0, which is a shell glyph, and this allows for position, so more complex numbers and counting systems. So let's do a very simple practice here. This is going to add up to 5, 10, 1, 2, 3, 13. All right, so let's get into the thick of it now. How would you count to 20? Would it be 5 different bars? So this is where we really start to understand the counting system here. We're using a decimal system here, so it's a base 20. This is obviously in contrast to the decimal system that we're used to, which is a base 10 counting system. So from 10 to 100 to 1,000 to 10,000, we're multiplying by 20. So 20, 400, 8,000, 160,000, etc., etc. So given that 20 essentially recycles the counting system, right, from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where 10 is the recycle point, we use the position here of 0, and then we use a 1 position. So this dot no longer represents 1, it represents 20. This is what I meant earlier by saying that these are equal to 1, but also to a 1 position. So let's get more complicated here. Let's say the number 819. Since we're up 2 positions now in the 20 count system, each dot is going to be worth 400. Now we're using the 0 shell to create a position between the 800s and the 1 counts, so the 19 number. So that's pretty dope. We're able to count to extremely large numbers. Now, how could we be certain that they're calculating these numbers accurately in the first place? We'll go deeper into this another day, but these calendar systems essentially give us that certainty. So these octoons essentially are 144,000 days. This is what gives us that famous December 21st, 2012 or whatever day where people are freaking out. It's essentially like counting a new millennia, right? You know, for us decimal counters, 1,000 years is a big deal. So this counting system has its sophistication, it has multiplication, it has exponentiation, it has the 0 counts positional systems, and you're able to essentially create complex maps with this kind of stuff. You know, as modern people today, we tend to look at people in the past as, you know, more simple or whatever, but they were mostly concerned with the same things we were concerned with: constructing society, figuring out how to look at the skies to plan agriculture, how to plan cities and stuff like that. When you're looking at this kind of material, it's kind of important to humble yourself, not to consider them so, you know, simple. Let's put it that way. You know, humans have always been complex, and that's really important to understand and to internalize as you study this material. All right, folks, catch you later.